This is a support video for S3 and National 4 Analogue Electronics. This time we're looking at task 10. And in task 10 we're initially told that an electronic engineer is required to redesign the circuit B from task 8 to make it simpler. So on the screen here we've got task 8, this task 8 circuit B circuit. And just to remind you, we've got a lamp, a diode which will only allow current to flow in one direction, which will be from the 9-volt voltage rail down to the 0-volt voltage rail, and we've got a switch so that we can control as and when we want the current to flow. Now, a component called an LED, or a light emitting diode to give it its full name, will be a component which will allow us to be able to simplify this circuit a little bit. And here's an LED right here. Now, the name and the symbol, light emitting diode, gives you a clue that it's very similar to a diode that we've already come across. The difference is that this diode is light emitting. It still controls the direction that will allow current to flow, but if current is flowing, then this will illuminate kind of similar to what a lamp would do. So in having a light emitting diode, we can now remove the diode from a circuit and a lamp, and we've got a component here which will allow light to come out as an output from the circuit. Now I'm just going to attach this just now to the circuit and connect it up, and I've deliberately connected it up in the wrong orientation. There's a little gate. The symbol is given as the arrow to give us a clue as to what way it will allow current to flow, but just to prove that it's in the wrong orientation, if I close this switch, then we've got indicators to show that there's current flowing, but nothing actually happens at the LED. So one of the first things we're going to do to correct that is simply rotate it to change its orientation. If I connect this back in, I've still got a potential problem now, because if I close that switch, both the switch and the LED have blown. Now, the reason for that is because the current flowing into the LED is far too high. That means we need to control the current. We've already learned from previous tasks that we can use resistors to control current. So I've now connected in a resistor, 680 ohms, just as it has come out of the browser. And if I press that switch to close it, then we can see that current can flow and the LED illuminates. To simplify the circuit further, the ammeter is only there to read current, but actually we've got no great need to be reading current in this particular circuit, so I can remove it to simplify our circuit a little bit more. However, what's important to notice is that if your resistance is too high, and just to over exaggerate it to make the point, put in 10,000 ohms or 10 kilo ohms, if I close that switch, we can see that current flows, but the LED doesn't light up. We've controlled the current far too much. Similarly, the current didn't have to be as high as the original 680 ohms, so if I changed it now to 270 ohms and close the switch, we can see that that illuminates perfectly well as well. So, LEDs, very similar to diodes. The only difference is that while they allow the current to only flow in one direction, they also light up. They are essentially a device which will convert electrical energy into light. But also, we have to bear in mind that we need to use resistors so that we can control current and make sure that we protect our LED from failing or exploding.